drawing. In this lecture we find out the length of line segment X. In the drawing we have a regular hexagon. A regular hexagon is a closed polygon with 6 equal sides and 6 equal angles. All those 6 sides are equal to each other, and all the 6 interior angles are also equal to each other. So, because of the fact that one side of this regular hexagon is equal to 2 units, therefore the other sides must be also equal to 2 units. So we can write down that AF equals to 2 units, FE equals to 2 units, side ED equals to 2 units, side DC equals to 2 units, side BC equals to 2 units, side AB equals to 2 units. And we know that all the 6 interior angles, those 2, 4, 6 are also equal to each other. And we also know that line segment PB equals to 4 units. And our mission is to find out the length of side AP that is equal to X. Okay, so first of all, we'll find out the sum of the angles in any regular hexagon. So I'll draw a regular hexagon and we calculate the sum of its angles. So this is regular hexagon. A, B, C, D, E, F. We join points B and D together by a straight line. By joining points B and E, we actually created two quadrilaterals, quadrilateral ABFE and quadrilateral BCDE. We know that the sum of the angles in any quadrilateral is equal to 360 degrees, therefore the sum of the angles of quadrilateral ABFE is equal to 360 degrees. And also the sum of the angles of quadrilateral BCDE, it is also equal to 360 degrees. And the sum of the angles in this regular hexagon will be equal to the sum of the angles in those two quadrilaterals. Therefore, the sum of the angles in this regular hexagon will be equal to 360 degrees plus 360 degrees, that is 720 degrees. So the sum of the angles in any regular hexagon is equal to 720 degrees. And because of the fact that any regular hexagon has 6 equal angles, it means that the size of one angle in any regular hexagon will be equal to the sum of the total angles, that is 720 degrees, over the number of angles that any regular hexagon has. Any regular hexagon has 6 angles, so the sum of the total angles over the number of the angles will be equal to the size of one angle. So 720 degrees over 6 is 120 degrees. So we found out that each angle in any regular hexagon equals to 120 degrees. So we can write here that this angle equals to 120 degrees. This angle equals to 120 degrees. All the interior angles in this regular hexagon will be equal to 120 degrees in their sizes. Okay, this angle equals to 120 degrees, and also those two angles are equal to 120 120 degrees. All the internal angles in any regular hexagon will be equal to 120 degrees. Okay, in the next step, we'll extend side DC by a straight line. DC is one side. Repeat again. Repeat again. That DC is one side of this regular hexagon, therefore it is absolutely a straight line. We extended the straight line DC by a straight line. We define this point as L. When you extend a straight line by a straight line, the result must be a straight line, so DL must be a straight line. We'll write it down. DL is a straight line. And we have rule number 1 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side, you can say that is the left side of the straight line DL at point C. Here the sum of the angles must be equal to 180 degrees according to rule number 1. So which angles we have at this side of DL at point C? We have this angle that is equal to 120 degrees. Plus the missing angle, that is actually angle BCL. In total, the sum of those two angles must be equal to 180 degrees according to rule number 1. Here we subtract 120 degrees from this equation and we get that the missing angle BCL equals to 180 degrees minus 120 degrees, it is 60 degrees. So we found out that the missing angle BCL equals to 60 degrees. In the next step, we'll draw perpendicular from point B on DL. Again, we'll draw perpendicular from point B on DL. So here, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. By doing this construction, we get that here. Here we will define the touching point of the perpendicular from point B and DL as M. By doing this construction, we get that here the right triangle BCM. Okay, so I'll copy the right triangle BCM and we'll analyze it. So this is the right triangle BCM that I copied from the original drawing. This angle equals to 60 degrees, angle BCM equals to 60 degrees according to rule number 1. This angle equals to 90 degrees according to our construction. BC equals to 2 units because of the fact that it is one side out of 6 sides of the regular hexagon, and all the sides of the regular hexagon are equal to each other. Each of them is equal to 2 units. So therefore BC equals to 2 units. So in this triangle BCM, cosine 60 degrees equals to CM over CB. CM over CB. So cosine 60 degrees equals to CM is the missing 9 segment, so we leave it as it is, over CB. CB equals to source, so we substitute CB by 2. In conclusion, we found out that cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2, and it is equal to CM over 2. So 1/2 equals to cm over 2. You will multiply this equation by 2 and we get that cm equals to 1 unit. Here cm equals to 1 unit. Also we can write here in the original drawing that cm equals to 1 unit. Okay. We continue to focus on the right triangle BCM. On the right triangle BCM, sinus 60 degrees equals to BM over CB. Okay, BM is the missing line segment, so we leave it as it is. CB equals to 2 units, therefore we substitute CB by 2. Sinus 60 degrees equals to square root of 3 over 2, so we substitute sinus 60 degrees by square root of 3 over 2. So square root of 3 over 2 equals to BM over 2. Here we multiply this equation by 2 and we get that BM equals to the square root of 3 units. BM equals to the square root of 3 units. You can write here that BM equals to the square root of 3 units, and here also BM equals to the square root of 3 units. In the next step, we will focus on the right triangle PMB. PC is unknown, so we define PC as A. CM equals to 1 unit. Therefore, in total PM equals to PC plus CM. So PM equals to PC, that is A, plus CM, that is 1. So in total PM equals to A plus 1. BM equals to the square root of 3 units, and the hypotenuse PB equals to 3 units. So I copy the right triangle PMB in a new page, and we will implement here the Pythagoras theorem. So this is actually the right triangle PBM that they copied from the original domain. PM equals to A plus 1 units, BM equals to the square root of 3 units. This angle equals to 90 degrees according to our construction. And BP or PB equals to 3 units according to what is given as the equation. So here, by PT is evaluation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle PMB is PB, therefore the square of the hypotenuse is PB squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM squared plus BM squared. Okay, so we found out that in the right triangle PBM, according to the Pythagoras theorem, PB squared equals to PM squared plus BM squared. PB equals to 3, so PB squared is 3 squared, that is 9, and it is equal to PM squared. PM is A plus 1, therefore PM squared is A plus 1 squared plus BM squared. BM is square root of 3, therefore BM squared is square root of 3 squared, that is 3. So in conclusion, we found out that 9 equals to A plus 1 squared plus 3. Here we subtract 3 from this equation, and we get that 9 minus 3 is 6, and 6 equals to A plus 1 squared. Here we'll take a root out of this equation, and we get that the square root of 6 equals to A plus 1. Here we'll subtract 1 from this equation, and we'll get that A, the missing line segment A, equals to the square root of 6 minus 1 units. So we can write here that A equals to square root of 6 minus 1 units. In the next step, we will join points A and C together by a straight line. Angle ABC, this angle is 1 out of 6 interior angles of the regular hexagon, and therefore it is equal to 120 degrees. Side AB equals to 2 units, side BC equals also to 2 units. So I copy triangle ABC in the new page and we'll implement here the law of cosines. So this is actually triangle ABC that I copied from the original drawing. Side AB equals to 2 units, side BC equals to 2 units, and the missing side is side AC. The missing side is side AC. Angle ABC equals to 120 degrees, and the missing side is side AC. We find out the value of AC according to the law of cosines. The law of cosines is true in any triangle. So if we have here triangle ABC, that could be any triangle, not necessarily our triangle, but any other triangle. This is triangle ABC. The length of side AB is a unit, side AC equals to B units in its length, and side BC equals to C units in its length, and the angle between side AB and side AC is theta. In this triangle ABC, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. I repeat again, in this triangle ABC, that could be any triangle. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. We will implement the law of cosines in our triangle ABC. According to the law of cosines, in this triangle ABC, AC squared equals to AB squared plus BC squared minus 2 times AB times BC times cosine 120 degrees. Repeat again, in this equation is the implementation of the law of cosines in our triangle ABC. According to the law of cosines, AC squared equals to AB squared plus CB squared minus 2 times AB times CB times cosine 120 degrees. Okay, so AC squared equals to AB squared. AB is 2, therefore AB squared is 2 squared, that is 4, plus BC squared. BC is 2, so BC squared is 2 squared, that is also 4, minus 2 times AB is 2, and BC is also 2, and times cosine 120 degrees, it is minus 1/2. Here we have minus times minus, that is plus. So in total, this number will be a positive number. So we have here 2 times 2, that is 4, and 2 over 2 is 1. So those 2 will get cancelled. And this expression in total equals to 4. So we have 4 plus 4 plus 4, that is equal to AC squared. So AC squared equals to 4 plus 4 plus 4 is 12. Here we substitute 12 by 4 times 3, so AC squared equals to 4 times 3. Here we take a root out of this equation and we get that AC equals to the square root of 4 times 3. We take 4 out of the root and we get that AC equals to the square root of 4 is 2 times square root of 3. Inside the root we left only with 3. So we found out that AC equals to 2 times square root of 3 units. So we can write down in the original drawing that AC equals to 2 times square root of 3 units. I will copy again triangle ABC in order to find out the value of those two angles. Okay. So this is triangle ABC that I copied from the original drawing. In this triangle ABC, side AB equals to side BC, they are both equal to 2 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So in front of those two equal sides, we have those two equal angles. And those two equal those two angles are equal to each other. So if one angle is x, then the other angle will be also equal to x. And we also know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ABC. So which angles we have in triangle ABC? We have x plus 120 degrees, that is equal to 180 degrees. X plus x is 2x, so 2x plus 120 degrees equals to 180 degrees. Here we subtract 120 degrees from this equation, and we get that 2x equals to 180 degrees minus 120 degrees is 60 degrees. 2x equals to 60 degrees, we divide this equation by 2, and we get that x equals to 30 degrees. So here x equals to 30 degrees, and this is actually angle ACB, that is equal to x, that is also equal to 30 degrees. So I can write down in the original drawing that this angle ACB is equal to x, it is equal to 30 degrees. Okay? So we know that the big angle PCB, this angle equals to 120 degrees. So I'll copy this angle PCB. This is angle PCB that is equal to 120 degrees. It is one out of the 6 interior angles of the regular hexagon, and therefore it is equal to 120 degrees. The small angle ACB equals to 30 degrees. Repeat again, this small angle ACB equals to 30 degrees. Therefore, from the drawing it is very easy to see that the missing angle PCB, so angle PCA, the missing angle, will be equal to the big angle PCB minus the small angle ACB. That is to say, angle PCA, the missing angle, will be equal to the big angle minus the small angle. The big angle is 120 degrees, that is angle PCB, minus the small angle, that is angle ACB, it is 30. So it is 120 degrees minus 30 degrees, that is 90 degrees. So I actually found out that the missing angle PCA, is actually angle PCA equals to 90 degrees. So actually this is a right angle. And because of the fact that angle PCA equals to 90 degrees, it means that triangle PCA is a right triangle. So we can implement the Pythagoras theorem in the right triangle PCA. So this is the right triangle PCA. So I'll copy the right green triangle, triangle PCA in a new page, and we'll implement here the Pythagoras theorem. Okay. So this is actually the right triangle, triangle PCA that I copied from the original drawing. This angle equals to 90 degrees. This is actually the big angle, that is over 20 degrees minus the small angle, that is 40 degrees, therefore it is equal to 90 degrees. Side PC equals to the square root of 6 minus 1, that is actually A. And we have already found out that AC equals to 2 times square root of 3, and we are looking for the value of A, the hypotenuse AP, that is equal to X. So we will implement here the Pythagoras theorem in order to find out the value of the hypotenuse AP that is equal to X. So here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle, triangle ABC, is AP, therefore the square of the hypotenuse is AP squared, and it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to PC squared plus AC squared. So according to the Pythagoras theorem, in this right triangle, triangle APC, AP squared equals to PC squared plus AC squared. AP is X, therefore AP squared is X squared, and it is equal to PC squared. PC is square root of 6 minus 1, therefore PC squared is square root of 6 minus 1 squared plus AC squared. AC is 2 times square root of 3, therefore AC squared is 2 times square root of 3 squared. So in conclusion, we found out that X squared equals to square root of 6 minus 1 squared plus 2 times square root of 3 squared. We will find out the value of this expression, square root of 6 minus 1 squared, according to the algebraic identity that A minus B squared equals to A squared plus B squared minus 2 times A times B. In our expression, the value of A is square root of 6, and the value of B is 1. And therefore, the value of this expression, square root of 6 minus 1 squared, according to this algebraic identity, will be equal to A squared. A is square root of 6, so A squared is square root of 6 squared, that is 6, plus B squared. B is 1, so B squared is 1 squared, that is 1, minus 2 times A is square root of 6, and B is 1. So in conclusion, we found out that the value of this expression, square root of 6 minus 1 squared, equals to 6 plus 1 minus 2 times square root of 6. So we return to our equation that X squared equals to square root of 6 minus 1 squared equals to 6 plus 1 minus 2 times square root of 6 plus 2 times square root of 3 squared. So in conclusion, we found out that X squared equals to 6 plus 1 is 7, so it is 7 minus 2 times square root of 6, and 2 times square root of 3 squared, it is 2 squared, that is 4, times square root of 3 squared, that is 3. 4 times 3 is 12, it is plus 12. In conclusion, we found out that X squared equals to 7 plus 12, that is 19, minus 2 times square root of 6. Here we will take a root out of this equation, and we will get X, that we get that X, the line segment that we are looking for, is equal to either the square root of 19 minus 2 times square root of 6, or in terms of numbers, x equals to 3.755 units. Repeat again. The 9 segment that we are looking for, x equals to 3.755 units, or it is also equals to the square root of 19 minus 2 times square root of 6, all under the square. In the next step, I will summarize the lecture. In the drawing, we have a regular hexagon. A regular hexagon is a closed polygon that has 6 equal sides and 6 equal angles. All those 6 sides are equal to each other, and all those 6 interior angles are also equal to each other. In addition, we also know that one side of this regular hexagon is equal to 2 units, therefore all the other sides also must be equal to 2 units. And we have to find out the sum of the angles in any regular hexagon. So I drew here a regular hexagon that could be any regular hexagon. This is the regular hexagon ABCDEF. In order to find out the sum of the angles, the sum of the interior angles in this regular hexagon, we join points B and D by a straight line. By joining points B and D, we created two quadrilaterals, quadrilateral ABFE, this quadrilateral, and quadrilateral BCDE. We know that the sum of the angles in any quadrilateral is equal to 360 degrees, therefore the sum of the angles in quadrilateral ABFE is 360 degrees, plus the sum of the angles in this quadrilateral that is also 360 degrees. And therefore the sum of the angles in this regular hexagon will be equal to the sum of the angles in those two quadrilaterals, that is to say it is 360 degrees plus 360 degrees, that is 720 degrees. Okay, so the sum of the angles in any regular hexagon is equal to 720 degrees. But we also know that any regular hexagon has 6 equal angles. And therefore, what is the size of one angle? It will be equal to the sum of the angles in the regular hexagon, that is 720 degrees, over the number of angles, that is 6. 720 degrees over 6 is 120 degrees. So we found out that each angle in any regular hexagon is equal to 120 degrees in its size. So here, all those interior angles are equal to 120 degrees in their sizes. Okay, in the next step, we extended side DC by a straight line. We define this point as L. DC is the side of a regular hexagon. It is absolutely a straight line. And when we extend a straight line by a straight line, the result DL must be a straight line. So here, DL is a straight line, and we have rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the left side of the straight line DL at point C, here the sum of the angles must be equal to 180 degrees according to rule number 1. So which angles we have at this side of DL at point C? We have this angle that is equal to 120 degrees plus the missing angle, angle BCM. In total, the sum of those two angles must be equal to 180 degrees according to rule number 1. So here we subtracted 120 degrees from this equation and found out that the missing angle, angle BCL, equals to 180 degrees minus 120 degrees, it is 60 degrees. So here the missing angle equals to 60 degrees. From point B we draw perpendicular on DL. And again from point B we draw perpendicular on DL. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. by doing this construction, we created the right triangle, triangle BCM. So I copy the right triangle, triangle BCM in a new page, and we analyze it. This is the right triangle BCM. This angle equals to 60 degrees according to rule number 1, and this angle equals to 90 degrees according to rule construction. BC equals to 2 units because of the fact that all the sides of the regular hexagon, they are equal to each other, and each side equals to 2 units. BC is one side out of the 6 sides of the regular hexagon, A, B, C, D, E, F. Therefore, it is equal to 2 units. In this triangle, triangle BCM, the right triangle, cosine 60 degrees equals to CM over BC. Cosine 60 degrees equals to CM over CB. So cosine 60 degrees equals to CM. CM is the missing answer, so we leave it as it is. And CB equals to 2 units. So we substitute CB by 2. And cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2. In conclusion, found out that 1/2 equals to CM over 2. We multiply this equation by 2 and found out that CM equals to 1 unit. Here, CM equals to 1 unit. Likewise, so we can write down in the original drawing that CM equals to 1 unit. Likewise, here, sinus 60 degrees in triangle, the right triangle CBM, sinus 60 degrees equals to BM over CB. Sinus 60 degrees equals to BM over CB. So BM is the missing isolate, so we leave it as it is, and CB equals to 2, so we substitute CB by 2. Sinus 60 degrees is square root of 3 over 2, so we substitute sinus 60 degrees by square root of 3 over 2, and it is equal to BM over 2. We multiplied this equation by 2 and found out that BM equals to the square root of 3 units. Here, BM equals to the square root of 3 units. In the next step, we focus on the right triangle, triangle PMB. What is the length of PM? PM equals to PC plus CM. So PM equals to PC. PC is unknown, so we define the size, the length of PC as A, and CM is 1. Therefore, in total, PM will be equal to PC plus CM, that is to say it is A plus 1. BM is equal to 3, and the hypotenuse BB equals to 3 units according to what is given as the question. So this is the right triangle, triangle PBM that I copied from the original drawing. I repeat again that PM equals to A plus 1, BM equals to the square root of 3 units, and the hypotenuse BB equals to 3 units according to what is given as the question. We implemented here the Pythagoras theorem in order to find out the value of A. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the surface of the perpendiculars. The hypotenuse is PB, therefore the square of the hypotenuse is PB square, and it must be equal to the sum of the surface of the perpendiculars. That is to say, it must be equal to PM square plus BM square. PB is 3, therefore PB square is 3 squared, that is 9, and it is equal to PM square. PM is A plus 1, so PM square is A plus 1 square, plus BM square. BM is square root of 3, so BM square is square root of 3 squared, that is 3. So in conclusion, found out that 9 equals to A plus 1 square plus 3. We subtracted 3 from this equation and found out that 9 minus 3 is 6, so 6 equals to A plus 1 square. We took a root out of this equation and found out that the square root of 6 equals to A plus 1. Here we subtracted 1 from this equation and found out that A equals to the square root of 6 minus 1 unit. Here, in the original drawing, you can write down that A equals to the square root of 6 minus 1 units. In the next step, we join points A and C together by third time. By joining points A and C, we created this triangle ACB or ABC. Angle ABC equals to 120 degrees because of the fact that it is 1 out of 6 internal angles of the regular hexagon, and we know that all internal angles of this regular hexagon are equal to each other, and each of them is equal to 120 degrees. So angle ABC equals to 120 degrees, AB equals to 2 units, and BC equals to 2 units. So this is the triangle ABC that I copied from the original drawing. AB equals to 2, BC equals to 2, and angle ABC equals to 120 degrees. In order to find out the length of side AC, we implemented here the law of cosines. The law of cosines is true in any triangle, so this triangle ABC could be any triangle. We know that the length of side AB is A units, side AC equals to B units in its length, and side BC equals to C units in its length, and the angle between side AB and side AC is theta. Then according to the law of cosines, C square equals to A square plus B square minus 2 times A times B times cosine theta. Again, C square equals to A square plus B square minus 2 times A times B times cosine theta. We can implement the law of cosines in our triangle ABC. According to the law of cosines, in our triangle ABC, we will get that AC square equals to AB square plus BC square minus 2 times AB times BC times cosine 120 degrees. Again, AC square equals to AB square plus BC square minus 2 times AB times BC times cosine 120 degrees. So AC square equals to AB square. AB is 2, so AB square is 2 squared, that is 4. Plus BC square. BC is also 2, therefore BC square is 2 squared, that is 4, minus 2 times AB is 2, and BC is 2, and cosine 120 degrees is minus 1/2. So in this expression we have minus times minus, that is plus. So in total this expression will be a positive. So here we have 2 times 2 is 4, and 2 over 2 is 1. So those two will cancel, and this expression in total equals to 4. Therefore, AC square equals to 4 plus 4 plus 4, that is 12. So AC square equals to 12. We substituted 12 by 4 times 3, so AC square equals to 4 times 3. We took out of this equation and found out that AC equals to the square root of 4 times 3. We took 4 out of the root, and the square root of 4 is 2. In conclusion, we found out that AC equals to 2, and inside the root we left only with 3. So AC equals to 2 times square root of 3 units. Here we found out that the length of side AC is 2 times square root of 3 units. Okay? Then I copied triangle ABC again in order to find out the sizes of those two angles. This is triangle ABC that I copied from the original drawing. AB equals to 2 units, BC equals to 2 units. And this angle ABC equals to 120 degrees. Because of the fact that side AB equals to side BC, we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if one angle is x, then the other angle must be also equal to x. And we know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ABC. So which angles we have in triangle ABC? We have x plus 120 degrees. In total they must be equal to 180 degrees. X plus x is 2x, so we have 2x plus 120 degrees, that is equal to 180 degrees. Here we subtracted 120 degrees from this equation and found out that 2x equals to 180 degrees minus 120 degrees, that is 60 degrees. 2x equals to 60 degrees, we divided this equation by 2 and found out that x equals to 60 over 2 is 30. So we found out that x equals to 30 degrees. This angle x equals to 30 degrees, and this angle ACB equals to 30 degrees. So we can write down in the original drawing that angle ACB that is equal to x, it is equal to 30 degrees. Then, in this drawing, we have angle PCB, the big angle, that is equal to 120 degrees. It is 1 out of 6 interior angles of the regular hexagon, and each of them is equal to 120 degrees. The big angle PCB, equals to 120 degrees. The small angle ACB equals to 30 degrees. This is the small angle ACB equals to 30 degrees. So it is very easy to see from the drawing that the missing angle, this missing angle equals to the big angle, that is angle PCB, minus the small angle, that is angle ACB. So angle PCA, the missing angle PCA, equals to the big angle that is 120 degrees minus the small angle that is 30 degrees. So in conclusion, found out that the missing angle, this angle PCA, equals to 120 degrees minus 30 degrees, that is 90 degrees. And because of the fact that angle PCA equals to 90 degrees, that is to say it is a right angle, therefore triangle PCA will be a right triangle. So we implemented the Pythagoras theorem on the right green triangle, triangle PCA. This is the right green triangle, triangle PCA. So I copied this right green triangle PCA in a new page and we implemented here the Pythagoras theorem. Okay, so this is actually triangle the green triangle BCA that are coming from the original drawing. Side PC equals to the square root of 6 minus 1 units. It is originally the value of A. AC, we have already found out that AC equals to 2 times square root of 3 units. And the hypotenuse PA equals to X. X is the line segment that we are looking for. So by implementing the Pythagoras theorem, we will find out the value of X. And according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. The hypotenuse in the right triangle EPC is AP, therefore the square of the hypotenuse is AP squared. And it must be equal to the sum of the sides of the perpendiculars, that is to say, it must be equal to PC squared plus AC squared. So AP squared equals to PC squared plus AC squared. AP is X, therefore AP squared is X squared, and it must be equal to PC squared. PC is square root of 6 minus 1, therefore PC squared is square root of 6 minus 1 squared, plus AC squared. AC is 2 times square root of 3, therefore AC squared is 2 times square root of 3 squared. Then we found out the value of this expression, square root of 6 minus 1 squared, square root of 6 minus 1 squared, according to the algebraic identity that A minus B squared equals to A squared plus B squared minus 2 times AB. In our expression, square root of 6 minus 1 squared, A equals to square root of 6 and B equals to 1. And according to this algebraic identity, A minus B squared equals to A squared plus B squared minus 2AB, we get that square root of 6 minus 1 squared equals to A squared, that is square root of 6 squared, that is 6, plus B squared. B is 1, so B squared is 1 squared, that is 1. So it is 6 plus 1 minus 2 times A is square root of 6 times B, that is 1. So in conclusion, we found out that the value of this expression, square root of 6 minus 1 squared, equals to 6 plus 1 minus 2 times square root of 6. Now we return to our original expression, that x squared equals to the square root of 6 minus 1 squared. We have already found out that the square root of 6 minus 1 squared equals to 6 plus 1 minus 2 times square root of 6. And 2 times square root of 3 squared equals to 2 squared, that is 4, times square root of 3 squared, that is 3. So 4 times 3 is 12. In conclusion, we found out that x squared equals to 6 plus 1 minus 2 times square root of 6 plus 2 times square root of 3 squared, and 2 times of square root of 3 squared is 12. 6 plus 1 is 7. So x squared equals to 7 minus 2 times square root of 6 plus 12. Okay, and 7 plus 12 is 19. In conclusion, we found out that x squared equals to 19 minus 2 times square root of 6. Here we took a root out of this equation and we found out finally that the line segment that we are looking for, that is actually AP, that is equal to x, it is equal to either the square root of 19 minus 2 times square root of 6 units, or in terms of numbers, x equals to 3.755 units. Okay, thank you very much.